So the main problem we were faced with was to replace the current coal mining electricity generation plant by a more sustainable option, therefore providing enough heat and light for around 2,000 inhabitants of Svalbard. The main design criteria involved, the source must be consistent, so it shouldn't be subject to many variations. It should also have a minimum impact on the ecosystem of Svalbard, meaning very low CO2 emissions, no disturbance of marine or other wildlife, and very little visual or sound pollution. From the national perspective, it should also pay back within its lifetime.
The problem is that Longyearbyen solely relies on coal power for its energy, which is very unsustainable. Not only that, but it's also very detrimental to the extremely fragile ecosystem and its polar bears.
There are multiple stakeholders that are affected by the sustainable energy project. These include the local workers, specifically the coal miners who may lose their jobs, also the funders for the project such as the World Bank and the Norwegian government. Let's not forget the polar bears in the Arctic ecosystem who are vulnerable to CO2 emissions.
Technically feasible. It is technically feasible as Norway is well known for its renewable energy. It will make the process a lot simpler as there is available technology and experienced companies that could guide this project. Can be constructed by local engineers with some help from the original companies that designed Seagen and Gravitricity. This will allow for experience exchange between different companies. The ocean depth and its wave speed are appropriate with Seagen criteria. It has a lot of mine shafts that are no longer in use. This can be converted into storage system to store energy once it exceeds the demand.
Despite the fact that demands for coal in terms of energy generation will decrease, this will allow the locals to specialize in export, therefore creating new jobs and increasing the amount of coal to be sold. Also, relationships between Norway and other nations like the UK will be strengthened. We are also creating an international hub for research purposes in terms of renewable energy.
Economically viable. Since the design idea is to install 4 Seagen turbines, we are likely to have excess amounts of energy. Despite that, excess energy can be stored and sold to another country, such as an ongoing agreement between Norway and Germany. Norway supplies electricity to Germany for a decent price. As Svalbard is located in relative proximity to Sweden and Finland, a similar cooperation could be considered. Since initial costs are relatively high, the design is supposed to pay back in less than 10 years.
Wave tidal and current energy are renewable sources of energy. This means that in the long term, Longyearbyen does not need to worry about its energy sources running out. In addition to this, there will be a decrease in emission of greenhouse gases if this plan is adopted. The reason being that when coal is burnt, greenhouse gases are emitted, and by adopting this plan, the people of Longyearbyen will be allowed to receive energy from a source other than coal.
The main idea is to create a system of interconnected underwater turbines that generate electricity, which is then transferred to the mainland via private wire and stored in a mineshaft-based system. Energy can be distributed throughout Longyearbyen using an existing coal power plant to provide energy to 1,000 households. A system of 4 water turbines is supposed to generate around 17.5 gigawatt-hour each, which sums up to 70 gigawatt-hour annually. Next, energy is transferred to mainland by a private wire which is connected to Gravitricity system. Essentially, Gravitricity consists of a piston in a cylinder which is suspended down a mine shaft. When energy is stored, heavy weight is raised in the shaft so that air is compressed and then the weight is lowered to generate energy.